Okay, we're back. Episode 10, number 10, I think. Twisting arrows, arrow sudoku. Let's just get started. Yeah, just note for the channel, 10 on those noties. I'm not going to be posting that crazy, so I hope not. So whenever one comes, just get a quick little reminder. Because they do come irregularly and whenever I feel like it. No schedule. Anyway, got Twisting Arrows by basically Asparagus. Okay. We've got, custom. Okay, well the main rule here is the arrow. The numbers along the shaft of an arrow must sum to the number at the base. So this is the base of an arrow. Let's say this equals 7. These two must sum to 7, so it could be 3 and 4. Or it could be 5 and 2. Pretty simple, yeah? Like level 2 maths. And this is custom. The arrow starting in row 9, column 7, okay, there, goes straight up. Okay, so that's that arrow, which means that arrow is like that. Okay, that is good to know. It's also nice and almost symmetrical across this. The center line, which is really nice. Okay, let's get started then. Okay, well, so that has to be the sum of those 4 digits. Okay, let's say the minimum value these 4 digits can take would be what? Would be a 1 there and a 2's there, which is a 6. So there has to be at least a 6 up there. Because it adds up to 6 without breaking any of the classic rules. But then what? Well, this would have to add up to 10, which isn't possible. Right, so that can't be a 6. Right, okay. As symmetrical, that would be the same for this cell down here. Okay, what if we think about this as, so let's say these cells must sum to that number, right? So these pink cells must sum to that orange number, and then these yellow cells must sum to that red number, right? So what we can say is these pink and yellow cells sum to the sum of these 2 cells, right? So all 7 of these cells here will sum to the same number as these 2. Okay, so what's the lowest these 2 can add up to? So the lowest here we can have here is 1, 2, 3, 4, and a 1, 2, 3, which gets us 7, 8, 9, 10 on this side, 6 on this side. So 16 is the lowest we can get to. Well, 16 is the lowest we can get to, which means this also has to be 9, 7, 8. And if it is 16, it's a 7, 9. But we can get to 17 by making this, instead of 1, 2, 3, a 1, 2, 4. Or this could be a 1, 2, 5. Because this now it has 6 on this side, 8, 9, 10, 11. Okay, well we can't sum, so it's either these 2 have to either up to 16 or 17. No, or 18 on 19 it is, right? Because 18 would mean 7 and 9, and 19 would be 8, 9, and we can't have... No, it would be 16. What am I... My math is awful. No, not 18. We can't get 18. Because 18 would be 2 9s, that's not possible. So it's either 17 with a 9 and an 8, or a 16 with a 7 and a 9, which means there is a 9 there. Okay, let's uncolour these. Cool. So we do know there is a 9 at the top. And this can be 1, 2, 3, 4, 5, or this can be 1, 2, 3, 4. And this sums to 16 or 17. And what? Right, so we know this is either, these three is either 1, 2, 4, or 1, 2, 3. And this left one is either 1, 2, 3, 4, or 1, 2, 3, 5. So it's either the two... Actually, we'll just... I've got a feeling we're not going to need to use these cells over here. So we'll just mark them. Actually... Yeah, we'll do a little bit lower, actually. Okay. So these cells here, on the right hand side, either have to be a 1, 2, 3, or a 1, 2, 4. And these cells on the left either have to be a 1, 2, 3, 4, or a 1, 2, 3, 5. And if we add up to 16, those add up to 16. And then these add up to 17, and those add up to 17. Right, okay. Because that's 6, 7. Yeah, that's it. So the two pinks are 17, the two blues are 17, and the two oranges are 16. Okay, so that's how this works out. And just ignore these cells, because that's got no... That's just me visually remembering what they have to be. And that is symmetrical to that. So, we can... What is true here is... And here is also true down here. So the short line is 1, 2, 3, 4. Oh no, well that's not the short... Yeah, the short line's 1, 2, 3, 4, 5. And 1, 2, 3, 4. Okay, well this 9, both these two 9s tell us that there is not a 9 down here. So there's no 9. Let's just say, I think they'll get lower than 4 on both sides. Because the 3 would require a 2 and a 1. Well, okay. That's good. So this here is either one of these two options. Which means we know there is a 1 and a 2 here. And either a 3 or a 4. Guess that's the same here. We know there is a 1, 2, 3 here. And either a 4 or a 5. Which means over here we also know there's either a 1 or a 2. Okay. Where to next? Okay, well, given we can't have a 1, 2 here, and this is a straight line, this has to have... We can't have a 1, 2, so this has to be 3, 3, 4 would make 7, 3, 5, or 3, 6. And the lowest 3, 4 can make is 7, okay, right. So it have to be a 7 or an 8. Right, so it's not 3, 6. But But that's not the same up here, is it? Because that's not a straight line. Okay, this can still be a 4 because you can go 3, 1. Okay, we know this can't be an 8 now, actually. Because let's say this is a 3. That would have to be a 5 to make 8. Oh no, it could still be 8 actually. Okay, well, it looks like these 4 of the 5 lowish numbers, which doesn't surprise me. Okay, oh yeah, okay, that makes sense actually. So these 3, it's either the 1, 2, 3 pairing like this one, or the 1, 2, 4 pairing. Right, and there is either, so there's either a 3 or a 4 here, which means this can't be 3 and 4. So that's not a 7. So that's 8. And we can't do 2 4s for 8. So that's an 8 now. Okay, well that's our 7, 9 now as well. Which means that can't be a 7. Well, 3, 5 there now makes that not be up to 3. That's a 1, 2, 4. Okay, that helps. So given we know there is a 1, 2, 4, this has to be a 17. Up the top. Because there's... yeah. Because that can't go with the 1, 2, 3, 5. They'll make 18. And we can't get 18 up here. So this is also... and because it's a 17, we know this has to be... no, this has to be an 8, 9, given now we're a 17, right? And that can't be an 8, so that's the 9, and that's the 8. Which means 17, this is the 1, 2, 3, 4. So that's not the 5. And that's the same here, right? No, this is the 7, 9, which means it's 16. Which means we have the 1, 2, 3, 4, the orange over here. We have the 1, 2, 3 over here. There's no 4 there. And we can't do anything about that, can we? Okay, I think we can move this now. I don't think we'll need it anymore. Because that was to figure out what these two were up here. Okay, that looks much better. I am becoming a ghost. Okay, we have these digits, which means the last 2 in this row have to be the 7 and the 6 in here. Oh, we do have a 1, 2, 3, 4 quadruple here, which means these other digits have to be 5, 6, 7, 8, 9. Whoa, that's colours. What am I doing? Whoa. Okay, so these have to be 5, 6, 7, 8, 9. Obviously 9 can't go there, because 9 plus something won't equal a sudoku digit. That can't be the 8, obviously, because like that. Okay, to make 4, that would have to be a 1. To make 5, that would have to be a 2. And to make 6, that would have to be a 1. Okay, so we have either a 1 or 2 there. Because we can't be 7, 9. And we can't be 3. Okay. Let's see if this does anything. Guess we could do the same thing with these four and those two, right? Because obviously these two orange sums up to that yellow, and these two, let's say blue, sum up to that red. So these four orange and blue sum up to this. These two, okay, that makes sense. Ah, okay, that's where it helps us. So the lowest these can be is a 4. So the lowest that can be is a 4, 5. And obviously the lowest this can be is 1, 2. So the lowest sum we can get in here is 3 plus 9 is 12. Whoa, no, Ollie. Okay, so that can still be 1, 2. That's 1, 2 still, and that's still 1, 2. Okay. Then make sure. So the lowest this can sum to is 12. We're going to put it in yellow. The lowest the bottom can sum to is 12. Now we're also limited to what the highest can sum to, up here, which is a 6 and a 7, which is 13. Right. Okay, so we've got a similar thing, where the lowest is either 12, that means there can't be a 4 there, so it's either 12, which is 7, 5, or 13, which is 7, 6. We know there's a 7 up there. Okay, this gets us 12. So 12 can either be done 1, 2 with 4, 5. So that's 12. And that's the only way we can get 13. We can do 1, 3. Okay, we're back. Oh yeah, so these are like, that's meant to be read as 12, 13. That's 1 and 2. That's 4 and 5 there, right? Okay. Okay. So, to get 13, we can have 1 and 3. We can have it like that. Because 4 plus 4 plus 5 is 13. Or, we can have 4, 6. As that will also equal 13. So yellows can sum to 12, and then blues and reds sum to 13. So that can have a 6 in there. But both of these in common have a 4. Both of these in common have a 1. Now where to next? So if we go 1, 4, we'd have to go 5, 2 for 7. Yes, so it's... Okay, so we can't go 3, 4 to make 7. Actually, no, we can, because then we can go 6, 2 to make 7. Right, okay, that's tricky. Actually, what am I doing down here? That can't be a 5. Because there's a 5 already in the box. So to make 4, we need a 1 here, and to make 6, we would also need a 1 here. So that's a 1. Okay, we'll just put that 1 back in there. And that 1's meant that a 2 or a 3. Okay, that doesn't really help us at the moment. Ooh, it might actually, because that means the 1 is on the larger. Thing. There you go, good word. Okay, well, if we have the 4, the 2 and the 3, that gets us to 9 down here. But we can still get a 7 down here. By going 2, 2, 2, 3 would get us to 7. But we can't do double 2's. Oh no, we can do double 2's. Okay. Okay, that's interesting. So given that this... Okay, so these 4 are the digits 1 through to 4. These 4 are the digits 1 through to 4. So what we can say is that these 4 are also the digits 1 through to 4. Which means these 2 are different from these 2. Which means these 2 are the same as these 2. Okay. And these 2 are the same as these 2. So let's say this is 2 and 3, that means the 2 and 3 have to go in there. Okay. How do we make 9 with only 3 digits up here? Well, obviously we need 4, 3, 2. Right? So there's no 1 there. Because 4, 3, 2 is the only way to make 9 in 3 digits. Which means the 1's on the 8 here. That means we get 2 1's on the 8. Right? Means we get 2 1's on the 8. Because there has to be a 1 here, and there has to be a 1 here as well. And the only spots they can go are there. So we definitely have 2 1's on this 8 over here. Now to get 2 1's plus 2 digits to add up to 8, we need the other 2 to sum to 6. Which can be done by either 2 3's or a 4 and a 2. So let's say the 1's are here, that means the 2 3's are there. Right. But we can't have a 3 on this side. We can't put 2 3's there. So therefore we can't have 2 3's, right? Okay. Let's say the 1's are wherever, because they can't be in the same row. They have to be in the opposite rows. So would the 3's. Which means we can't do that. Because we can't have a 3 in these. And these have to be 1, 2, 4. So therefore to make this 8 we have to have the digits 1, 2 and 4. Which means these cannot be 3's. So we have 1's. And we have to have those digits. We have to have a 1, 2 and a 4. The 1's are either in those 2 or all in those 2. It doesn't help us over here, does it? Yeah, those can still be all the digits. Those can still be all those digits. that can't equal 5. Those can't equal 5. Because a 5 would need a 4 and a 1, or a 2 and a 3. A 6, a 1 and a 5, that could be done. Okay. That means both of them can't be a 6. Okay. So these 4 digits actually. I'm going to do the same thing. What is the minimum these 4 digits can sum to? And well, let's say that's a 1 and a 5, which is the lowest those two can be. Then we can go 2, 6. So 1 and 5 is 6, 2, 6 is 8. So this these can sum to is 14. Yes, 6 plus 8 is 14. So last these can sum to is 14. Which means, let's say this, if this is a 9, to make this equal 14, we'd need a 5 up there, and we can't get a 5, so that can't be a 9. And 14 can't be made of 2 7s, so that can't be a 7. So now that's a 6. We can't make, and to make these, well, it can go higher than 14. So this isn't a 7 either, because so it can be 14 or 19 here, really. Same sketch how I got there. I don't really trust it. Okay, so let's go again. That's to be 5, 6, 7, 8, or 9. Let's put them all back. Run through the logic again, make sure I'm not making a massive mistake. That can't be an 8. Okay. The lowest these 4 can sum to is a 1. It has to have a 1 and a 2 across here, and a 5 and a 6 across here. 5 plus 6 is 11. A 1 plus 2 is 14. Okay, wait, we can rule out the 5 first, because 1 plus whatever, if it's in here, cannot equal 5. What are we saying? 5 plus 6 is 11, 1 plus 2 is 3, 11 plus 3 is 14. A 9, so these would have to sum to 14. And we can't have a 9 there. We can't have a 9 there because we'd have to have a 5 up there, which we proved is impossible down here. So there can't be a 9. And, oh no, we could be higher. Yeah, that's right, we could be higher. So we can't rule out the 2 7s yet. But the same reason we can't have a 9 up here is the reason we can't have a 9 down here. And the highest we can sum to here is now 7. Plus 8 is 15, so it's either 14 or 15. And to get 14, we would need 6, 8. And to get 15, we would need 7, 8. Okay, so does that mean 8 has to go there then? Yes, I did mess up. To get 14, we can't do 2 7s, so we have to do 6, 8. And to get 15, we'd have to do 7, 8. And that can't be an 8 because of that. And can't be a 9 because they can't sum to. Why can't it be 9 actually? Because 9 plus 5. Why did I rule out a 9 because it was couldn't sum to 14? But what if it summed to 15 with a 6? So it could still be a 9. Yeah, it could still be a 9. Wait, okay. So we've gone nowhere. I'm glad I checked that again. What makes that can be 9? That can be an 8. Okay, that can't be a 9, right? Because if that's a 9, that has to be a 7. So it makes it 16, or 17, like that. What did we say this, the minimum this could sum to? 1 plus 2 is 3. Oh, this sun, bro. I'm going to close that. 3 plus 11 is 14. Okay, 14, Ollie. And 6 plus 8 gets us to 14. Okay. So we've got nowhere in the last 20 minutes. Cool. Okay. Let's see if this has magically changed. Mind, these are not actual solutions, they're just me brainstorming. And we can remove these now because we know it is a 1, 1, 2, 4. For that to be a 5, it would have to have 1, 4. And then the next we could have is 2, 7. Which would be 7. There was a 5. If it's a 5, it's 1, 4. Which means the others are 7. But if it's a 7, well, you can do 7 so many ways. Well, let's say that's a 7. These two have to add up to 6. Which means we would have to have 4 of the 2 or the 5 and the 3. Four, 2, 5, 3, which means this has to be the 1 and the 6. So what I'm hearing is that if we're making 7, it has to include the 1 and the 6. That is what I am hypothesizing right now, right? Okay. So let's say we make this any combinations of the highs and the lows, so 1, 6, 5, 2, 4, 3 all make 7. Okay. Or we can make 5 of them with full 1. Which means it has to be 5, 2. What we can say is that in this box, the 8 and the 9 has to go here. Given they can't go on the top and they can't go there. Which doesn't help us. Okay, let's say there's not a 5. Let's say there's a 5 at the top. Actually, no, that doesn't help us. I really don't know where to go here. If you have seen something that would break this puzzle apart, let me know. So we know that's a 1, 1, 2, 4. Right, okay. Maybe look at this. So the blues are used if this top are 6 and 7. Or could be. And can we get the blues to sum to 6 and 7? Yes, with 4, 2 and 6, 1. Can we get the reds to sum to 6 and 7? Yeah, with 3, 4 and 1, 5. Get the top to can we get to 12 at the top and made 5 and 7? Yeah, which is 1, the 1 and a 2 and a 5. 2 and a 4, 1 and 6. 5 with the 2. Or 5 with the 1. To make 7. Yeah, no, that doesn't help. Ah, that's probably it. Where does 8 go in this column? Can't go in this box because there's 8 already there. Can't go there, so that's where the 8 is. Wow. That was 100% what I needed to do ages ago. If you found that, props. But obviously I didn't. Okay, and to make 8 here, 4 plus 4, so we can't have a 4 there. 3 plus 5, 2 plus 6, or 7 plus 1. Cool. So we know these sum to 8. So to get this to 6, we can use 1, 5. To get this to 7, you can use 2, 5. To get this to 9, we can either use 2, 7, or 4, 5. Right, 6 has to be 1, 5. 7 can be 1, 6, or 2, 5. And 9 can be 2, 7, or 4, 5. Right, doesn't help us. If I can rule 9 out of here, this would be massive. Right, given there has to be a 5 and a 6 up here. That doesn't really help. What am I doing? Right, so this blue can't exist actually. Right, to get this top two to be 13, we need 6 and 7 up here. At the bottom, we would need 1 and a 2 and a 4 and a 6, which means we would have 2 6s in the box. So the blue doesn't exist. So it's either yellow with 1, 2, 4 and a 5. Blue doesn't exist, so we can't have 4, 6. That's completely independent. So we know we have 4, 5 here. Right, depending if we have 2, 3, we could have... The 6 at the top would mean 13. which means we'd need to have a 1 and a 3 in the left. And whatever doesn't go there has to go up here now. Oh, that means there's a 5 in here, right? So that can't be a 5. Which means we do sum up to... We do sum up to 13. Using 4, 5 and 1 and 3. Okay, I should have got there ages ago as well. Another thing that if you picked up, well done. Okay, and then that we've got 4 pairs, which means our last digit up here is 2. And our 7 is obviously our 4 and our 3, and our 6 is our 1 and our 5. Cool. And then my other question is, can we get 7 on a long one? Down here, because this is probably another thing I probably should be able to figure out. 7 on a long means we need 4 digits that sum to 7. And it can have a 4, and it can... two ones, 2, plus can't do, and 2 twos would get us to 6, so we can either do... Oh, that's 7. So that's how it would have to get to 7. There's no other way we can get to 7. Which means our 1, we would have to have a 1 there if we wanted to get to 7. And a 1 either in one of these two. Wherever, the 3 would go there. We're going to need 4, 2, plus 3. That's if the 3 goes. If the 3 goes there, that would be a 2. Okay. That's just plugging values. So let's say those are the 1s. That's the 2, that's the 3. So this then has to be the 3 and the 4. And that can't be a 2 then, because that's the 2. Right, no matter where we place this... Right, to get to 7 on this long one, we'd need the 1s to be there, right? So these can't be 1s. And no matter where we place the 1s, wherever we place, if the 1s we place in those two, the 2 and the 3 would be placed there, and that can't be a 2 and a 3. And we place the 1s in those two, 2 and 3 would be placed down the bottom here, and that can't be a 2 or 3. Which means the long one can't be the 7. So the long one is the 9, and the short one's the 7, which makes that the 6 up here, and the 7 up here. The 7 had to be done by the 4 and the 3, and that's the 5 and the 1. Okay, cool. So the 7's on the short, the 9's on the long. Cool. That 1 and the 4's obviously made that a 2. 4, 1, okay. This is solving itself for us down here. Okay, to get this to sum to 9, that needs to be the 2. That's the 1, that's the 4. Cool. That seemed to have worked pretty nicely. Yeah, obviously that's our 1, 3. This is now our 2, 4. Because we know our pink digits are the same. And to get 7 through these, a 3, 2, 2 would get us to 7, okay. Can we use the 4 on 1, 2, 3 would get us to 7? Can that be a 3 and us get to 7 here? No. Because if that's a 3, we'd either need 2 evens or 2 odds. And we can't do that, so that can't be the 3. That's our 2, and by sudoku that should just fill out this box. Okay, maybe not. Maybe that's as far as we get. Actually, no, we do. The 2 2s plus the 3 is what gets us to 7. Our 1s go there, our 3s go there. Cool. Get this to 8, that needs to be our 7. And that can't be a 6 now. So 4 plus 5 gets us to 9 with our 6 in the middle. That 6 has made that a 7, and that a 6. That 3 has made that a 5, and that a 3. 1 plus 5 is 6. Cool. I feel like we've used every single hint now. Now it's just time for some normal sudoku. Let's start with the 1s. We need a 1 down here. A 1 here. A 1 in the corner. Our 2s. Need a 2 here. A 2 there. A 2 in the corner. And a 2 there. Our 3s. A 3 there. A 3 at the bottom, which makes that a 1. 3 at the top. 3 there. That one would make that a 1. Our 4s. We've got a 4 over here. Which means there's a 4 there. A 4 goes there. We have a 4 in here. And then we've got a 4, one of those, which I won't bother marking. 5s. I don't want to mark that actually. Yeah, so we get a 5 up to the top, which puts a 5 down the bottom. Puts a 5 there. 5 there. That's about it. Our 6s. Go there. There. At the top there. There. Our 7s. Yeah, we know there's a 7 down there, which puts a 4 at the top. Which puts a 3 there and a 6 there. That 3's... Did that 6 impact anything? No. So we've got our 2 pairs here, our 4, which we still don't know. Our 6s. Our 5s. Okay, cool. Where are we up to? We're up to 7. 7 needs to go here. Okay, we've got a 7-6 pair here. Which means that's our 5. Our last number's obviously a 9 in there. This feels good. It feels like I have not made a mistake. Okay, that number is an 8. What other numbers could we figure out? That has to be a 6-7 pair. Yeah, which makes sense. Cool. That is a 1, 2, 3, 4, 5, 6, 8, 9 pair. That can't be the 8, so that's the 9. Which means that is a 2, 5 pair. And that's the 2 then. That's now the 5. That's now a 2. This last digit is our 9. Which makes that our 9. Our 4 there. And our last digit in here is a 7. That's a 6, a 7. Last digit in this row is a 9. And this column is a 6, which means there's an 8. In this row we are missing a 5, which puts a 5 up there and a 6 in there. What are we missing there now? 8. And now in the box we are missing a 4. That's now 7 and a 6 up there. In the row we are missing a 7, and that means our last digit here is an 8. Cool. Yeah, that was nice. It took a while for me to get a few of the little tricks with the arrows. However, it was just normal Sudoku after that, which, you know, pretty easy, pretty comfortable. Hopefully you followed along during both parts. The weird, complicated trial and error arrows, and then the more straightforward, simple Sudoku rules. Yeah, that's it. Might be back sometime soon. Who knows? Yeah, who knows? The next one we will do is Crucinea Rods, which looks pretty interesting. Okay, peace. I'm joking. War.